let's get started, everybody. Welcome to CE 312. Welcome to Structural Analysis. I think most of you know who I am. I think I've had just about everybody in here for class before, right? Most of you for geomatics, right? Maybe a couple of you for CAD or statics and whatnot. Just in case you don't know who I am, I'm Dr. Michelson. I'm going to be your instructor this semester for the lovely world of structural analysis. I'm going to break one of the unwritten rules of PowerPoint and sort of show you one of my best slides first, namely about that little girl right there. That is Stephanie. That is my daughter. She was supposed to stay a baby, but she didn't. She just kept getting bigger, and that's a problem. Here in this photo, she is very much in a dynamic situation. She's moving. This is a statics-based course, so things are going to be sitting still. I did have to teach her how to prepare some invoices this summer because she started losing her first couple of teeth. So that's where we're at with her. And this is my lovely wife Becky there in the bottom, and Stephanie, an earlier beta build version of in addition to being the instructor for this course, I serve as the college's associate dean, which means I mainly manage the academic side of things. So if you have issues with course registration or degree works or all that jazz, you can come see me. My office is literally one floor up. I'm in the dean's suite, 2103A. There's my email address, pretty easy to get a hold of. As for my background, I am a registered professional engineer. I got my PhD from that school up north at WVU, and my background is structural engineering. I'm a bridge engineer. That's what I do. I design and work on bridges. My main focus is on steel bridge design, and mainly focusing on bridges in the short spans, usually anything that's like about 150 feet or less, because that comprises the bulk of what we build in the United States. Most people, when they think bridges, they think Golden Gate or New River Gorge Bridge. But the average length of a bridge in the United States is really only about 50 feet. I mean, if anybody drove on Interstate 64 to get here, you see a lot of those bridges being constructed, but you'd be surprised how many small bridges you drove across. And so that's what we spend a lot of our taxpayer dollars on. So it's what a lot of my research is focused on, ways of making the process of installing those bridges faster and cheaper. So I could go on and on about that, and I probably will mention stuff here and there, but it's the first day, and let's talk about, the class, okay? So let's go through the grade breakdown. I'm going to pull up the syllabus here in a little bit to sort of give you some more detail, but I wanted to give you the big picture of how the class is structured, no pun intended. This is the grade. I have a very modest attendance grade, which I do. If you've had me for class before, I break out a QR code for attendance. I'm going to break out that here in a second. Homework is the biggest part of the grade because this is one of those sciences where doing matters, and so I want to encourage you doing the work. We do have a project in the class. I have been doing this project now for about 4 years, and most students, if you ask students that have had the class before, generally describe the project as being pretty fun. It's not a terrible amount of work. I'll go ahead and tell you what the theme of the project is. The theme of the project is essentially designing a bridge that connects this building to the biotech building. And so you're going to be designing and laying out a truss that will carry pedestrian traffic essentially across the third floor of this building to the biotech building. And so that involves sizing the members, ensuring that they are strong enough and that the bridge doesn't deflect too much. And then the goal is to try and come up with the cheapest bridge possible. So it's not a ton of work, but it's pretty fun. It gets you thinking outside the box. We do have 3 exams in the class. Of course, I don't refer to these as exams. We don't have exams in college. We have celebrations of learning. So we're going to be celebrating 3 times this semester, 2 during the semester and 1 during finals week. They are not comprehensive exams. I don't do that. But some of the material does bleed over from exam to exam, and there's just sort of like no way around that. But they're not intended to just build on. They're topic-based exams. This is the book. I don't care if you get a digital copy of the book or a physical copy. I do think that you should have a structural analysis reference. I mean, we're getting to the point in your education where we're talking about classes that are going to relate to what you do in your careers, okay? And so this stuff matters. I want to be clear. I'm not saying that, it doesn't matter if you keep your history book or not, but I mean, you're civil engineering majors. This is a very important civil engineering class. So having this as a reference, I think is a good idea. But I won't micromanage if you decide to get a digital download or buy a copy. It's whatever you want. Most of the homeworks will come out of this book. For the first few assignments, I will probably assist you in terms of like posting what the structures look like in case some of you are still waiting for your textbook via the mail and whatnot, because I know that would be kind of a pain, but after a while I'm just going to assign straight out of the book, okay? That's big picture, okay? Any questions so far? Good deal. Okay, let's talk about how we operate the class, the logistics of day-to-day and what have you. Okay, so let's talk about technology. Blackboard. I'm going to use Blackboard pretty heavily in the class, mainly for posting the grades, attendance grades, homework grades, all that. Lecture notes, all the homework assignments are going to be posted to Blackboard. In fact, they should have, a lot of this stuff should have become visible today. I set it to turn on at 10 a.m. So I'll have pretty much everything that you need in order to negotiate the class posted to Blackboard. A lot of what we're going to be doing in this class in terms of submitting homework, what you're going to do is do the homework and then submit it to Blackboard using, so basically I just want you to submit like a scanned PDF. A lot of students will use something like CamScanner or Microsoft Lens. Either one's fine. Those are completely free. And I have had students who what they'll do is they'll take their like iPad, do the homework, and then just like upload that. That's fine too. I really don't have a problem with how you choose to get the homework from here to Blackboard. You can do that however you want. I have some pretty loose formatting guidelines. If we want to, and they're in the syllabus, I'll pull them up here in a bit. But long and short of it is, if the homework is neat and legible, it's going to be fine. So I just don't want the homework to be sloppy, okay? Laptops, okay? So we're not going to use laptops a lot this semester, but there are going to be some days in which we do, okay? Around the Halloweenish time frame, like late October, early November, I'll have to pull the schedule up, see here in a bit. We're going to be using a software package called Masthand to analyze structures. By the way, Masthand is both PC and Mac friendly, so I chose that package for that very reason. So you will want to bring your laptops those days. I'll make sure that you're aware of it well in advance, but we are going to be doing some analyses in class. You're also going to need Masthand for your project, for your class project in here. But we aren't going to use that until much later in the semester. For the most part, this semester and this course, the best way of describing it is Statics 2. If you're wanting to get sort of a flavor of what the class is going to be like, it's a lot like that. So that should sort of put you in the mindset of what class is going to be like from day to day. Statics 2, but much more directed towards civil engineering applications. Okay. Microsoft Teams. I'm going to use Microsoft Teams primarily for periodic announcements. I'll go ahead and level with you. So one of the things I've been doing for a long time for courses like this, and I think you all probably remember this from Geomatics, is that I would use the class notebook inside Teams to do the problems, right? So what I'll do is I'll do the problems like here on the screen, and then they get recorded inside the class notebook. The cool thing about that is that it's sort of like everything that I write on the board is digitally preserved and accessible to you all 24/7. I actually tried to activate the OneNote yesterday, and I was getting IT, hiccups, so I'm still following up on that. We're not going to be doing any calculations or anything today, but my goal is to do the problems on OneNote so that for here for the rest of the semester, anything that we do on the board, you can access 24/7. Other than that, and the Masthand package that we're going to use later, we might have some packages here and there. There are a couple days we are going to use Excel for very specific reasons, but it's not something we use regularly. We'll use Excel sparingly in here. Obviously, browsers and Adobe Reader and so on and so forth. So far, so good? Okay. Speaking of, one thing that we are going to use when it comes to attendance is the QR code. Let me pull that up. So this is how I'm going to collect attendance. That link should take you to a Google form where you just put your first and last name, and that's how I'll collect attendance every day. Pretty straightforward. Every day I will start class with an announcement slide that looks something about like this. It'll just contain basic info on where we're at in the class, what we're going to be talking about that day. I usually try and start out if there's something going on campus or something that you need to know about, like the canoe and the bridge team has their conference coming up, or there's a career fair. I'll try and put it here just to make sure that you're aware. Which, by the way, I guess one important announcement are my office hours. My daughter's in kindergarten this year, and so her school lets out at 3 o'clock. So I said, well, I have class from 10 to noon. I'm going to be picking her up. I'll just make my office hours like every day at around this time frame. But I'm also the associate dean, so I'm kind of around quite a bit. So if you need to get a hold of me, it's not like I'm inaccessible. I also am pretty accessible via Teams and whatnot, so you can always reach out to me if you need. Okay. Everybody get the code? Everybody good? Okay. Typically what I do for attendance is it's full credit if you're here. If you're late, it's half credit. And if you're not here, obviously it's no credit. And I'm pretty easy to get along with in terms of excused absences and things like that. I'm pretty easy to get along with in that regard. Okay. Okay. One thing that I will do, and I've been doing this for a long time, is I record my lectures and I post them to YouTube. I have a YouTube playlist that I have curated just for this class, and the link to that playlist is on Blackboard right now. So as I record lectures, I'll upload them to YouTube, and then I'll put them on that playlist so that you won't have to manage a number of links. It's all just right there, okay? And I'll say this, it might not be immediately posted, like give me a little bit of time, but my goal is to usually, for example, this semester I'm teaching this class, and then right after this I'm teaching statics. And so afterwards my goal is to just record them both, upload them both, and have them all done at the same time. Because I've got everything on Blackboard, and because I've got everything recorded, you're going to be, if you miss class, you're still going to be responsible for work. But I think you'll find the way this class is structured, that's not the biggest challenge in the world. Let's talk about homework. I do something different in this class when it comes to homework, and when I first tell students about this, their first reaction is to get alarmed, but you'll be surprised by the end of the semester how much you'll appreciate it. So I do a homework assignment essentially for every lecture, due at the following lecture, okay? So for example, we're gonna have a homework assignment Wednesday, due Friday. Another assignment Friday, due Monday. Then one Monday, due Wednesday. And we do that pattern pretty much the entirety of the semester. And so I know the first time you hear that, you go, oh goodness, we have homework every day? Yeah, but there's a couple things to keep in mind. For one, the homeworks are really short. Okay, they're not very long. We're talking 1 or 2 problems, and if there are multiple problems, they are really short. And you'll see what I mean after this first assignment. You'll probably be able to do the homework assignment in about 5 or 10 minutes. But there's a lot of advantages to doing it this way. For one, because the homework is right after the lecture, and pretty much based on what we talked about during the lecture, you're not having to remember something that we talked about 2 weeks ago in class. Oh, I have a homework due tomorrow and I forgot what we talked about. That kind of doesn't happen, Honestly, if you miss an assignment here and there, it's not the end of the world. Look at it this way. If I had a class where I only had 4 homework assignments, each one of those homework assignments would be pretty intense and pretty stressful. Whereas if I have so many of them, if you miss one, it's not the end of the world, If you take all that and add it up, most students at the end of the day actually like this system. What I basically did is, once COVID happened, I said I'm going to take the same amount of work that I did in a normal class and just spread it out. And basically what I get at the end of the day is, I'm the only one, I think, in our department that does this. So a lot of students think it's a nice little refresher, okay? Like I said, in terms of format, as long as it's neat, that's fine. I would like to see your name, CE312, like page 1 out of 2, 2 out of 2, what have you on the top. But other than that, it should be pretty straightforward. I will upload solutions to the homework as well on Blackboard. On per assignment, I will take work that's late. I usually assign a 20% late penalty for when it's late. But after it's graded or after the solution's posted, I won't accept it, because if you've got the solution, then you know what the answer is. But that's basically the gist in terms of homework. Like I said, there will be an analysis project in the class, and I've given you essentially the idea is that we're going to be designing a truss bridge that connects this building to the biotech building. You'll have a lot more details on that later. What I will say about the project is that I think there's a pretty nice balance between the project being open-ended enough that you can kind of do the project the way that you want, but closed form enough that it's not so unclear as to what you need to do. You'll be very clear on what you need to do, what boxes you need to check in order to complete the project, but you'll have the flexibility to do it the way that you want. There are 3 exams, 2 of them during the semester, 1 during the university scheduled final exam slot. So one thing is, if you've had me for class before, you probably remember me saying this, but if not, or it's been a while, I use a rule of 3 when I make exams. So what I do is I make the exam and I take the exam. And so my idea is, if I have a problem and I can do that problem in 10 minutes, you should be able to do it in 30 minutes, right? So I use a rule of 3 when I build exams, because whenever I started building, like my philosophy when it comes to being a professor, like how I want to go about things, one of the things I did is I made a list of all the things that professors used to do that annoyed me when I was in college. I said, I'm not going to do that, right? And one of the things that always used to annoy me was when I had a 50-minute class and I had an exam that took 4 hours. Like, that starts to become a test of how fast I can write numbers down and how fast I can press buttons on a calculator, as opposed to an exploration of my understanding of the topic. And so I really don't want to do that. I've never really had students in droves say that my exams were time crunches, and that's really something that always bugged me when I was a student, and I don't want that to be the case here. Again, I don't intend for exams to be comprehensive, but there are going to be topics that bleed over. For example, one of the first things that we're going to discuss in the class is how to compute support reactions. You have a structure, what are the external forces necessary to keep it in equilibrium? You need to understand how to compute support reactions in order to analyze a truss or draw shear and moment diagrams. Now, shear and moment diagrams are going to be on exam 2, and truss analyses are going to be exam 1. But support reactions are going to be on both of them, right? I can't really do anything about that. That's just sort of the nature of structural analysis. But I'm not intending for that to be a topic on both exams. I want the exams to cover what they're supposed to cover, okay? So far, so good? Okay, let me pull up, before I go to this, let me pull up the syllabus. I want to pull up the syllabus, and I want to pull up Blackboard, because I want you to sort of, again, get an understanding of what we're doing and why we're doing it. Okay, so here's the syllabus. It should be available on Blackboard. There's really nothing here when we get into the hyper-specific details that I haven't already mentioned. Again, there's my grade distribution, grading scale. I do round grades, by the way. So if at the end of the day you get an 89.5, that's an A. Okay, just that's a common question I get. I'll go ahead and answer that one. Communication policy. I would just say email and Teams. I tend to use Teams when it comes to class communication for 2 reasons. The first is if we wake up this one morning and there's a blizzard and it's a quick way of getting a note out to the students, I can do that. Or another reason I'll use Teams is if we have a homework assignment and I'm getting a lot of questions about this one problem, I'll tend to make a post on Teams because it's kind of quick and I want you all to get the feedback, because if you ask a question and I've got a good answer for that question that I think everybody else needs to hear, I'm going to send it out so everybody else can see it too. But it's a quick way of doing it. Does that make sense? But if I have a more formal announcement that's not as time sensitive, I'll probably send an email to the class. So I would just suggest check your email regularly. If you don't have your email app on your phone, you should by now. And then Teams, just have the Teams app available. Nothing on technology that I haven't already mentioned, and all the contact here about that. Our semester is longer this semester. You all are aware of that. We got an extra week, and I actually really changed this class a little bit, especially the tail end of it. And I'll explain what I mean when we get to the schedule. Homework policy, and then the submission guidelines, etc. ABET outcomes. You'll get what we mean as we go through that. I'll say a couple things. So ChatGPT, I'll just be honest. You can use it if you want, but I really don't think it's going to help in here. You'll see what I mean when we start getting through the classes. But one of the things I did a while back is I went to ChatGPT and I gave it like 5 numbers, and I said, compute the standard deviation of these 5 numbers, and it was wrong. So, use it for, at your own peril is all I would say. Okay, here's the schedule. Okay, let me zoom in a little bit. Okay, so one of the things that I try and do is I try and be pretty much a stickler when it comes to the schedule. So, for example, I told you we had 2 exams in class. That's when we're going to have it. Okay, so exam 1 is going to be on Monday, September 23rd. Exam 2 is going to be on Monday, October 28th. That, barring tornadoes or something drastic happening, that's our schedule. Okay, that's our schedule. I think I was able to work in the October break kind of nicely, because if you look, so is everybody aware we now have like a 2-day break in the middle of the semester in October? So we finish shear and moment diagrams, and then we come back from our October break. What I've done for the October break is, so our class project, it's going to be assigned right around the middle of September. There's going to be 2 submittals due. The first submittal is, I'll just go ahead and say it's very little work. There's not actually a lot of work that goes into the first submittal. Basically, the first submittal is forcing you to just think about the project for a little bit. What I do is, like I said, we're designing a bridge. I have you come up with 3 conceptual designs, and then I make you pick one and give me a reason why you pick it. That's submittal 1. It's really not a lot of work. So I'm going to have that due after the October break. But honestly, you could do it like right then. And again, it would take you like 30 minutes. It's really not a lot of time. If you want to use AutoCAD or be more neat, in your drawing, it might take you a little longer, but it's really not a work-intensive. It's not a work-intensive submission. The second submittal is. I'll level with you there. Okay. So I also think we worked out pretty well for Labor Day, because our first big topic is support reactions, and we're going to finish support reactions before we take Labor Day. So I think that worked out pretty well. So we have our first exam. Our first exam is going to be on Monday, September 23rd. It's going to be on the first topics in the class, which is stability and determinacy. We're going to talk about that Wednesday. Support reactions and trusses. That's really the star of the show for exam 1. For every exam, prior to the exam, we have an exam 1 review. What I do in exam reviews is what I've done for all my classes, which I come in for about 5 or 10 minutes, talk about the format of the exam, what it's going to be structured like, what types of questions you're going to ask. I'm not going to tell you what's on the exam, but give you kind of an idea of what to expect, and then the floor is yours. If you have questions you want me to go through, if you want to go through homework solutions, it's, you come in prepared to ask whatever you want, okay? So that's how we do our exam reviews. Exam 1, Monday, September 23rd. Exam 2, Monday, October 28th. And again, you can see on that second exam, it's meant to cover something else, like it's covering different topics. Now, where things get a little different in the class, this is much different than what we have done in previous semesters. One of the things that that I've wanted to do for a long time is cover matrix analysis. And matrix analysis is basically how the software program works. Like, I'm going to show you this software program, Masscan. What you're going to do is you're going to build a structure, then you're going to click a little button, and it's just going to analyze the whole thing. It's magic, right? But I kind of want you to understand how it works. Okay, if you've ever heard the term finite element analysis, it's basically the same thing. Finite element analysis has more broader applications, but it's all built on the same principles. So I want to spend some time covering that near the end of the semester. Not going to make it a whole course out of it, but just I want you to understand how these programs work. The other thing worth mentioning is the Friday before Thanksgiving break. What I'm going to do is I'm going to make myself available in case anybody has any questions on the project this Friday, November 22nd, but we're not going to have a formal class that day. So I'm not taking attendance. If you get the project done, you submit it, go have some turkey, you know. But if you need to come in and go through some questions on the project, I'm going to camp out and be here ready and willing. Okay? Does that sound good? And we got lucky on our exam slot because our final exam slot is Monday of finals week, Monday at 10:15. So it's right around the same time we have class, and it's the first day of finals week, so we don't have to wait till the very end. Yeah, so that is the structure and the layout of the class. And I plan to follow this outline pretty closely. There are a couple of assignments and a couple days where some of the assignments, like for example, I have homework 4 assigned here, and it's not due until this day. It's not, what I'm trying to do there is that one assignment may take a little bit more time, so I want to give you some time on it. It's like the software assignment, that'll take a little bit of time. And some of these assignments, when we get to the matrix analysis, might take a little bit longer, so I want to give you some time on it. Okay. All right. I see a typo on my numbers there on the matrix analysis stuff, but I'll be all right. Okay. Any questions as to how the class is laid out? Yes, sir.
I have one about. So, what is your policy for concealed carry in your office?
Sorry, that's a good question. So let's talk about that. So first off, I'll be global in my answer. First off, every professor should have this statement. That came from the university. That was so there's 2 syllabus policies. The first is the campus carry policy, which is required, like I guess by state law. And then there's the second policy, which is about your faculty office. I don't care. This is a short answer. I don't care. I'm fine. Yeah. So yeah. So there are some faculty, the point I'm at, there are some faculty that might care, and they'll have the additional second policy. I don't care. But that's a very fair question. Yes?
What about the fact that isn't the school getting rid of the Office suite?
The what?
Like the Excel, Word, PowerPoint? That's what I heard. That they're going to stop paying for it.
I haven't heard anything. Seriously, where'd you hear that?
Whenever one of my friends, he logged into it and said your school access is going to end at the end of this week. No, he got on, like,
oh really?
he opened it.
Because I got a Sam email that said the same thing.
Your thing's going to end. So,
So basically, when you're doing like half the work, cool.
I mean, I don't know.
Right, we just get half of it.
It's kind of news to me. Let me say this. I feel like I'd have heard about it. You know,
And the fact that you haven't heard about it is good for you.
Listen, that doesn't mean. I'm just saying I haven't heard that. So I'd be saddened if that were the case. So, but we'll be fine one way or the other. At least in this class, we'll figure it out. So, okay. Nothing that we do in Excel could be done in Google Sheets if you need it. I mean, we'll figure it out, but yeah. So. Is anybody else seeing this warning message? Everybody else shaking their head no. Right, so But if you hear that, you let me know, okay?
Okay.
I would like to know. All right. Any other questions? Yes.
Do students get free access to AutoCAD?
Yes, they do. So what you have to do, you have to create an educational account through Autodesk, but yes, you can. You have to renew it once a year too. But yeah, you can get free access.
I tried using AutoCAD over the summer, and if it tells you about the lessons and you just say no, it lets you keep going.
So what I have to do is I have to renew it once a year. So if I log in and then it gets angry at me, I have to re-log in and re-authenticate, and it works. So
I just kept telling me no, and kept doing anything.
I haven't had problems. So yeah. All right. I do have a few other things to talk about today, but before we move on, any other questions about the class organization? All right. Okay. Let's talk a little bit. So one of the things I always like to answer on day one is why you're in this class. Right? I mean, granted, you could give the cheap answer, which is you're civil engineering majors and degree work says you have to check this box off in order to graduate, which, I mean, yeah, that's true. But that doesn't answer why you're in the class. Why did we build the degree to make you take this? Why am I up here? Okay? So maybe what I should do is just take a step back and talk about what structural analysis is. Now, most of you have been exposed at least to some basic structural analysis when you took statics, okay? Everybody that took statics has probably seen a shear and moment diagram before, seen a truss before. We're going to do it a lot more in depth in here, but you've seen those before. So what is structural analysis? This is about the shortest but most concise definition that I think I can come up with. Structural analysis is the determination of the effects of the effects on physical structures and systems when subjected to loads. Okay, and so really the two key aspects of that definition are loads and effects, right? So loads being some action that we apply to a system, and then the effect being its response. Okay, and so loads could be a number of different things. Okay, and effects could be a number of different things. Let's go through effects first, since that's what I listed here. So the effects are things like how the structure responds. So support reactions. If I'm sitting here on this table, right, the table responds by developing forces here in the legs to keep the table in equilibrium. Okay, so those are support reactions. Internal forces inside the system. So if we're talking about trusses, things like axial forces, shears and moments in beams, etc., the internal response. What about deformations? Okay, when I apply forces to a system, it will deform. When you took statics, we assumed everything was rigid body. That's not the real world. The real world is that things deform. Okay, so what are those deformations? What are those translations, those rotations, etc.? Okay, those are effects. What about loads? Okay, so loads can sort of be broken up into two different categories. Like, the first are what I would call gravity loads. Gravity loads being those that act in the direction of gravity. So self-weight, or the weight of the structure itself, we tend to call those dead loads. Occupancy loads or transient loads, or what we call live loads. We'll get into more specific definitions of what these are later, but live loads, I tend to use the term occupancy load quite a bit because live loads correspond to what the structure is being used for. For example, we have specifications in civil engineering that will define what loads we should use for different types of structures. For example, in a classroom setting, it's common to use a floor load of something like 40 to 50 pounds per square foot. So every square foot of the floor, we assume that there's 40 pounds on it, and that's what we design the floor system for. So for classrooms, we might use 40 pounds per square foot. But for something like a library, we might use something like 150 pounds per square foot. Why the library? Why are the loads so much higher in a library than they are in a classroom? The books, right? Right? Because the library contains all the book stacks contained with all the books that college students don't read, right? So we have to design the floor system to hold that. That was a joke, not a very funny one. It's Monday, I got to throw it. you're gonna have to get used to really bad cheesy puns. You're just gonna have to get used to it. So I'm just getting you prepared for that right now. All right, another example of loads that we might see on structures are environmental loads. Wind loads are, structures have to be subject to that. Wind loads get a lot more tricky as the building gets taller, okay? Because as you get higher and higher, wind loads increase, and they tend to increase parabolically. How many of you have ever been on the top of a tall building, like Empire State? You ever been up top there? Is it windy up there? Anybody ever been up top there? Y'all need to get out more. Nobody's been on top of, like, go to the Empire State. Just go to New York, like one day. Just get out. Some other environmental loads, rain, snow, ice. We typically, so rain is a lot more of a localized effect. Snow tends to be globally what we worry about as structural engineers because snow accumulates and stays there, whereas rain can drain off. Another big one is seismic effects, earthquakes. There's no earthquake monster pushing on a building, but whenever the ground moves in an earthquake event, we apply an acceleration to a building, right? The building itself has a mass. Force equals mass times acceleration, and so you can get equivalent forces in a structure based on the fact that the ground is accelerating and the building is moving under that acceleration. So designing a structure to resist that's a thing in and of itself, okay? And so what structural analysis is the process of determining when you apply these loads to a system, what is the resulting response? What is the resulting effects? That's what we care about in this class. That's our goal, okay? So the question is, why do we care about that goal? Why do we care about determining those effects? The answer is design, okay? We care about properly analyzing structural systems because it is our job as civil engineers and structural engineers to design those systems. So what is structural design? Structural design is arranging and sizing all of the components of a structure to safely resist that demand. So things like let's say we're talking about a steel frame. Let's talk about the new Brad Smith business building. Some structural engineer had to design the beams, the columns, the connections, the bolts, the welds, the foundation, all of that in order to safely support all the loads that frame was going to be subjected to. That's structural design. And without, you heard it. I don't know what that was. In order to design that structural system, the engineers needed to know what they were designing for, okay? So that's what we're doing here. So this is sort of part one of structural engineering is this course. Part two would be what you take next semester, maybe structural steel design or reinforced concrete design or what have you. That's where we're going there. Okay, where do we start? Where do we start in the world of structural analysis? Well, first off, we got to adopt some basic tools. Equilibrium. So sum of forces and sum of moments. The structure should be in static equilibrium. What about Hooke's law? Y'all remember this? That should be familiar, right? So that the Hooke's law says that the structure behaves linearly, that there is a linear relationship between the applied stresses and the resulting strains. Okay? We're going to assume that structures behave linearly in an analysis setting, which is by and large the most common analysis estimate. Most engineers will assume linear behavior in structural analysis in about 90-95% cases, and then they'll assume nonlinear behavior from a capacity standpoint. So, but that's a steel design, concrete design question which you'll answer later. There's also compatibility. The displacements in the structure, how the structure should deform, should be continuous. No sudden jumps in displacements. Okay, so you'll see, like for example, here's an I-beam. This is sort of an animation of an I-beam deforming, and it's deforming under in a continuous fashion. Okay, and so we'll adopt those same assumptions when we start looking at beam deflections and truss deformations and things like that. Okay. Now the last thing I'll leave you with before we go is the idea of analytical modeling. So this is, I'm not going to talk a lot about this in this course, but it is an underlying fact that I want baked into your subconscious as we discuss structural analysis this entire semester. I've been lying a little bit in the fact that I've been saying we're analyzing structures. That's not entirely true. we're not analyzing structures. We're analyzing mathematical models that represent structures. Okay, that seems like a little bit too much subtlety for day one in a structural analysis class, but it is worth mentioning. Okay, so here's some real structures. These things are complicated. Okay, they're three-dimensional. They can exhibit dynamic behavior, nonlinear behavior. They are difficult to analyze, and so what we as engineers do is we take this behavior and we apply some assumptions to it, and we resolve this system into something that we can analyze. For example, here's something a little bit more basic, but a little bit more realistic. So for example, I have an image here of some roof trusses, right, that you would find in any residential environment or any commercial environment, okay? And what I'm gonna do is I'm gonna take these roof trusses and I'm gonna idealize it. This is a 3D system, right? 3D real world system. I'm gonna take it and idealize it into this, right? There's some lines and there's a triangle here, and a little thing with a wheel on it, and some, you know, letters and some arrows and loads, right? There is behavior baked into this model. There's assumptions that we have made that this model complies with, okay? Now, the reason that we made these assumptions is because this model is pretty easy to solve, particularly pretty easy to solve by hand or pretty easy to solve in software. But the underlying question you have to ask is, does the behavior of this model represent well enough the behavior of this, okay? And I would argue that it's actually one of the prime challenges in structural engineering, being given a structure and going, how should you analyze it? And you look at the connection conditions and you go, okay, I'm going to use a pin connection here. Or you look at another structure and go, that's not pin, that's fixed, right? It requires your understanding of what these models represent and how does that assumed behavior apply in the real world. Okay, again, that's kind of subtle, but it's really important, and it's probably one of the biggest challenges in structural engineering. Okay, like I said, kind of subtle, but that'll become much more important throughout the semester. All right. Any questions? Okay, so couple housekeeping. Oh, I know what I want to do. I don't think I did this. I wanted to pull up Blackboard. Okay, so here's Blackboard. Let me go to the student preview. So when you log into Blackboard, you should see something that looks like this. You should know you're in the class because you see a big old picture of the New River Gorge, right? Right now, you should see 3 links. You should see a link to the syllabus. So it's right there, and you can pull that down, review that. You should see a link to the YouTube playlist, which if you click that, should take you right to YouTube. There's nothing there because this is day 1, but there will be here in a bit. And then lecture notes and supplements. You should see, like the slides for today. And what I've done is I've got the slides for the next couple weeks available right now. And for our this topic, we're only going to talk about on Wednesday, and we'll be on this topic for a few days, okay? And so, for example, if you look here, you'll see several, slides and whatnot. Okay, as homework assignments populate, they'll show up here, okay? Sound good? Any questions? All right, one final bit of housekeeping. I'm going to stop the recording, but if anybody missed the QR code, I'll pull it up one more time. That's all I got, everybody. I will see you all on Wednesday.